Welcome to the Jurassic Park-Cast, the Jurassic Park podcast where guests chat with me about Michael Crichton's 1990 novel Jurassic Park, and also not that too. My name's Ryan Rogers, and I'm a big dumb Jurassic Park fan. Welcome to episode 19, Jurassic Park, and we're also in the third iteration, recorded here on a mild and sunny morning, June 21st, 2022. Thanks for joining me today. A big thank you to Christoph Oakes of Snail, the terrific band that gives us the music for our openings and closings. Check out his incredible album on Spotify and Bandcamp. Today's intro is from the song Late Bloomer, which I love. And our outro is Grow Old or Don't. We have some corrections. I've been pronouncing Dennis Nedry with only one N, when Dennis has two N's, and I should be better than that. And I'm willing to put in the work. Also, Salurosaurus wasn't a carnivore like I'd been sure it was, as mentioned in episode 16, Malcolm, with Dr. David Hone. There is nothing which is specifically a Salurosaurus. There was once a Colosaurus, which is what Crichton was probably referring to, and there are Salurosaurs, which is a huge family of stiff-tailed theropods, but there is no distinct Salurosaurus. The Salurosaurus was reclassified in 1979, it was once a thing, as an ornithomimus. It was reclassified in a paper co-authored by Dr. Jack Horner, which Crichton might have looked into, well, with his close attention to Horner while researching this novel. This was a herbivore and is of a vintage similar to that of many of the other animals in Jurassic Park. Namely, they're all from like around the 19th century. My mistake. What Dr. Wu is referring to was a herbivore, it just wasn't a valid species name any longer. And finally, when I made a list of dinosaurs that had their names changed back in episode 3, Almost Paradise, I included Deinonychus antiropus becoming a velociraptor and Microceratops becoming Microceratus, but I missed that Othnielia, a species that we'll meet in the park that bounces around after the storm and things like that, has also had its name changed. Like the Colosaurus, which became an ornithomimid, its shoddy paperwork led to its eventual reclassification, converting it to Nanosaurus. It is still known to be herbivorous, bipedal, and a basal ornithischian, but a variety of species are now grouped under the same moniker of Nanosaurus, the dwarf lizard. So no more Othnielia. In dinosaur news, today I've got two papers, and both have ties to our special guest, who's published on the cranial anatomy of dinosaurs, and in particular, the cranial anatomy of tyrannosaurs. At the risk of poorly summarizing academic papers, here is the news today. The first paper comes from the Journal of Vertebrate Paleontology called Quantifying Vascularity in the Frontoparietal Dome of Stegosaurus validum from high-resolution CT scans published on March 17th, St. Patrick's Day 2022. This isn't the famous Stegosaurus with the cool plates and spiked tail. This is Stegosaurus, which means roofed horn, and validum is Latin for strong or valid, as in making a great argument. These bipedal herbivores were about 7 feet long and had been uncovered from the late Cretaceous deposits in Alberta, Canada. As a species, they're either small or moderate forms of the Pachycephalosauria, with domed or knobby growths on their skulls with relatively short facial region, thickened skull roofs, small leaf-like teeth, and bony ornamentation of varying degrees in the snout and back regions. Leaf-like, think like, like a teardrop sort of thing. Not like a fern frond or something like that. There's so many different shapes of leaves. That's a goofy description. The lactotype CMN515 is housed at the home of Dr. Jordan Mallon, my guest from episode 5, The Beach, the Canadian Museum of Nature, and was uncovered in 1898 over in the Dinosaur Park Formation. It was formally described by the incredible Dr. Lawrence Lamb in 1902. In any case, back to the article. In a cranial scan of the pachycephalosaurid dinosaur Stegosaurus validum, researchers found that the thickened frontoparietal expanded dramatically during ontogeny from a flat-headed to a domed state, meaning Pachycephalosaurus, and in particular this Stegosaurus, would have had a flat area on its skull as a youth, and as it matured would develop more robust domes, by which they are famously recognized. Changes during ontogeny to the vascularity and bony tissue structure caused the expansion in the frontoparietal area. The researchers employed a script adapted from an algorithm for human cortical bone imaging to identify morphological landmarks throughout the aging of these animals, and were therefore able to compare, apples to apples, how specific areas in the skull changed as they matured. They argue that, quote, this tool enables 1, a complete assessment of bone vascularity from CT scans, 2, is applicable to any fossil or modern bone in the vertebrate skeleton, and 3, provides an alternative measure to pixel-by-pixel manual thresholding, a time-intensive and subjective process. So you can do a lot of good research in a lot of different places in a more timely fashion, thanks to some of the groundbreaking work they've done here. Furthermore, relating to skull scans of tyrannosaurids, the Journal of Vertebrate Paleontology published online on February 11th, 2022, the paper, The Cranial Anatomy of the Long-Snouted Tyrannosaurid Dinosaur Quanzhousaurus sinensis from the Upper Cretaceous of China. Whereas most tyrannosaurids are known for having deep snouts, thick teeth, and large jaw muscles that could generate high bite forces, these animals coexisted in Asia with a morphologically divergent group of long-snouted relatives called Alioramans. And this paper is about Quanzhousaurus sinensis from the Maastrichtian Age formations of Ganzhou, China. Quanzhousaurus is sometimes referred to as Pinocchio rex for its narrow snout and its therefore long nose, like that liar Pinocchio. Unearthed in 2010, this Chinese specimen is known from a nearly complete skull with lower jaws, though missing all its teeth, as well as 9 cervical, 3 dorsal, and 18 caudal vertebrae, both parts of the pectoral girdle, partial pelvic bones, and the left hind limb, including its femur, tibia, fibula, and pes bones. The specimens are housed at the Ganzhou Museum as a specimen number GMF 10004. It's named Quanzhou after the ancient Chinese name for the province Ganzhou, where it was discovered, and of course Sauros means lizard, and sinensis is Latin for Eastern, or in this case China, or Chinese. It was a slight tyrannosaur, a little over 20 feet long, and it was described in 2014. Beyond that, Alioramans are known to be long-snouted tyrannosaurs living throughout Asia, coexisting with other larger, more robust tyrannosaurs like Tarbosaurus, which is like a Mongolian a Mongolian tyrannosaur. They had sagittal crests on their parietals, which suggests exceptionally strong jaw muscles, and were bipedal with massive skulls filled with large teeth. Their skulls would have had fused and reinforced bones, making their bites strong. They had thick S-shaped necks, long, heavy tails balancing their big head and torso, and their mass would have been centered over their hips. And of course they had small arms bearing only 2 functional digits. Quanzhousaurus is the largest Alioraman yet found, and this paper presents a detailed osteological description of their holotype cranium and mandible, meaning it'll be filled with extraordinarily specific names and descriptions that perfectly illustrate what they're talking about, with the perfect nomenclature, so that it's so specific I couldn't possibly relate it in the common tongue. But they specifically state that they identify some newly described autapomorphic features distinct to the species of the genus, and new synapomorphies, features common among Alioramans as a clade. The paper argues that they predict that Quanzhousaurus' skull represents that of a mature individual and stands as an example of what a mature Alioraman skull will look like. And the features indicate a much weaker bite than deep-skulled tyrannosaurs, suggestive of differences in prey choice and feeding style. As a representative of a mature species, the paper says the authors can, quote, show that much of the variation among the Alioraman species is consistent with growth trends in other tyrannosaurids, and that Alioramus altai, Alioramus remotus, and Quanzhousaurus represent different ontogenetic stages of progressive maturity across which the signature nasal rugosities of Alioramans became less prominent. So this paper has phylogenetic implications across the study of the family of Alioramans. With the news and the corrections aside, it's time to meet today's really incredible guest. Joining me today is Dr. Eugenia Gold, the Assistant Professor of Biology at Suffolk University in Boston, Massachusetts, who earned her PhD in Comparative Biology from the Richard Gilder Graduate School at the American Museum of Natural History. Eugenia and I met after escaping from a minecart from the Temple of Doom, and then Mola Ram ambushed us on a rope bridge above a crocodile-infested river, and Eugenia began cutting the ropes and causing the henchmen to fall into the crocodile pits, and then it resulted in us hanging on for dear life from the remnants of the bridge. But instead of winding up in a dark and disturbing Indiana Jones sequel, she instead leapt down into the crocodile-infested river to answer the age-old question, should one ever smile at a crocodile?
It was a harrowing experience, but I'm glad we survived.
So you've done some work on gharials, is it?
Yeah, so for my master's project, I looked at brain case changes in the Indian gharial and how that compares to other crocodilians.
And can you smile at them? It won't be too dangerous?
I think it's distance dependent, so
okay.
As long as you're not right up in their face, it's probably fine.
So you can tip your hat and stop and talk for a while, but that's all right. Well, thank you very much for being a guest on this goofy podcast with me. You're
Happy to
taking
be here. Thanks for having me.
okay, you're taking time away from doing some of your much more important things, science communication projects, to do this with me instead. What sort of things have you got going on that I am taking you away from?
Well, I have science communication projects on every platform, I want to say.
Mm-hmm.
I recently published the Mandarin version of a children's book on women in paleontology called She
Okay.
Found Fossils. So now it's in English, in Spanish, and in Mandarin. You can find that on Amazon. I have a paleontology news blog for kids that's in English and Spanish. That's drneurosaurus.com.
Right.
And I recently started a YouTube show, Science on the Street, where I take science topics and present them in the style of comedy news programs like Last
Okay.
Week Tonight or Daily Show. So that's Science on the Street on YouTube.
That's neat. What was the name of the book again?
She Found Fossils.
She Found Fossils. Right, right, right.
We ran it as a Kickstarter in 2017, and it was fully funded in
Okay.
less than 24 hours. And we raised enough money to add on a third language, and we chose Mandarin because it's one of the most spoken languages on the planet. So we're trying
Yes.
to get as many people to be able to read it and access it as possible.
That's really neat. And certainly there's lots of fossils to be found in Mandarin speaking nations. So that's really neat.
For sure.
So you must be outspokenly high on your opinion of Jurassic Park because you were specifically referred to me for the purposes of this podcast. And then you said yes. So you must like Jurassic Park an awful lot to put your trust in a complete stranger like me to lead a discussion about the most fictitious of science fictions. So what is it about Jurassic Park that compelled you to say yes to join me today?
So many things.
Okay, good.
Jurassic Park. Jurassic Park came out when I was. So it came out in '93. Is that
That's right.
'93? I was 8. Okay, so I was not actually allowed to watch it in the theaters when it came out, even though I was already really into dinosaurs and my parents were fully aware of that. There was a household rule: you could not watch PG-13 movies until you were 12. So I actually had to wait several years before I was able to watch Jurassic Park. And when I was finally able to watch it, I watched it as like a fan, a dinosaur fan, someone who's a kid, a really interested in dinosaurs kid, as we all were, and some of us never outgrew it. And as the sequels came out, I ate them up, watched them as soon as I possibly could. And then I had this experience. I remember when I was doing my PhD project, I was on the megabus down to DC, and I brought this on my computer to watch as my entertainment, because of course. And I was finally able to watch it through the lens of a paleontologist.
Okay.
And it was a completely different experience for
Yeah.
me.
Yeah.
That I was able to empathize with, what Dr. Grant was visualizing and how he was feeling in all these scenes, and the actual terror of having these now living organisms chasing you. And it was really interesting. And then I finally, on the 20th year anniversary of Jurassic Park, was able to see it in the theaters
Okay.
when it was re-released, and it was really fun.
Did you see it in 3D?
Yeah, I did see it in
Yeah.
3D. That was the first time I watched it in the theaters, was in 3D, which I'm not really into 3D movies, but it was worth it for Jurassic Park. I made the sacrifice.
What I loved about the 3D experience was that it brought more to life even the opening scenes where you just have like the guy going down into the amber mine. That environmental setting really came to life. And of course, all the jungle scenes and stuff like that throughout the film were really good. But they were just those earlier kind of maybe forgettable moments. They really popped in 3D in a way that there's something to be said for how Spielberg captured the images on the screen, that when you put a little bit more attention into it, they still look really, really good.
It's aged very well.
Yeah, it's still cool. I just watched a special last night kind of on the transition between Jurassic Park and then into the Jurassic World. And all the clips were just from Jurassic Park. They weren't from Jurassic World. And because they were just baiting all that nostalgia to say, you guys love this movie. And so therefore go watch this other one. But that's how it's going to be. I love how, too, when you look back at it through the lens of a paleontologist, which I don't, but you can, that Grant manages to like weaponize his knowledge of dinosaurs, and so he can use it to fight off the raptors in the book. But at the same time, he can make that boy at the dig site feel shame because he can weaponize his knowledge of dinosaurs on him and stuff like that. I think he becomes a really cool hero that where knowing stuff about dinosaurs is a powerful tool instead of, I don't know, when you're a kid, it's kind of like your parents roll their eyes at you, you know?
For sure. Yeah. You get called a nerd a lot.
You don't need to know those names.
I'll show them. Now it's my job.
So I talked to people about how they rewatch the film many years later and they can see it through the lens of a parent where they didn't see it like that before. Obviously, we watched it through the lens of a child in our first blush. Are there other perspectives that maybe when you review the material that come to you that maybe you didn't see the first time around?
I've never thought about it that way. Yeah, the biggest change for me was going from a child, an enthusiast watching these to watching as a paleontologist.
Mm-hmm.
I will admit I have not rewatched it since becoming a parent.
Okay.
So that might be a different experience. I have noticed that now if there are children involved in the shows and movies I watch,
Mm-hmm.
I have like a instinctual reaction and it makes me much more upset. So I don't know that I'm ready for that, but
Yeah.
I'm hoping to rewatch all of them before I watch the last Jurassic World.
Good choice. I think that'd be a good choice. Your earliest memories when you finally got to watch the film, what are some of the highlights that really still linger with you as like your first reaction to watching it?
The big things for me were the T-Rex coming out of the fence.
Mm-hmm.
That still to this day, like I have the growl that it does as my ringtone.
That's the best.
And I actually legitimately have to keep my phone on silent because it scares me every single time it goes off. But I know in my heart that my phone is growling at me and it makes me very happy every time. So that scene, the one that terrified me the most as a child was the dilophosaurus attacking Nedry in the rain. I don't know why that one and not the velociraptor one, because velociraptors are one of my favorite dinosaurs, but the dilophosaurus scared me a lot as a child to the point of eventually having some nightmares based on dilophosaurus.
Yeah.
So those two. And then as I rewatched it, the classic scenes I always talk about from Jurassic Park include the Brachiosaurus rearing up on its hind legs and stomping, always the T-Rex. They actually, the science behind the T-Rex was actually pretty good.
Yeah.
They did a pretty good job. Those are the big three for me.
I think with the Dilophosaurus, it was so memorable because they added those kind of fictitious elements that, the spitting was in the book, the frill is not, but the frill made for such a great jump scare. It really was impactful because I remember, definitely going, whoa, the first time that frill comes out. Because if you rewatch it, you slow it down. It's not, the puppet doesn't do amazing things. It's kind of a little clunky, but when it happens that first time, it's kind of a playful, fun moment where Wayne Knight is kind of dawdling around, and it's kind of funny, and then it just changes gears fast. And you're right, unforgettable.
Yeah.
And
really impactful, especially as a child.
Yeah. And then I think with the raptors too, the other one that really got me was I guess it's that other jump scare where Ray Arnold's arm falls on Ellie's shoulder and she goes, oh. And again, it's that whole switch of dynamic where you're kind of at peace and the tension drops, and then she spins around, finds out that it's a severed arm, and then there's a raptor right on her again, just like that. And that was the pacing and the vision that Spielberg put into making those scenes were just, I guess, perfect, right? And they're really well put together.
The more experience I have with movie watching, every time I go back to it, it doesn't lose its appeal, even though the movie is over 20 years old now.
That's right.
The mix of robotics and CG was so well done that the CG doesn't age the way that fully CG movies, like the first Harry Potter, when it came out, I actually legitimately was confused as to how they filmed the Quidditch scene when it came out, and then 5 minutes later I realized it was CG and felt like very silly for having that thought process. But that doesn't happen with Jurassic Park. It blends so well that it feels very real.
Really good. I have to say, if for working in Boston, you haven't adopted the Boston accent the way You haven't acclimated very well there.
No, and I refuse.
Okay.
I
Is it?
refuse to pick up the Boston accent.
I haven't
I've,
spent a
I've
lot.
had to stop myself from saying wicked.
Okay.
So, yeah, my child is growing up here, and her nanny has a pretty thick Boston accent, and we're also trying to teach my kids Spanish, and so we have to try to convince her that the R's at the end of words are important because you can't use a Boston accent in Spanish because the words won't make any sense. So, yeah, it's a challenge.
That will be fun. So, I've read correctly that your doctorate is in comparative biology.
Correct.
So, when a student pursues a doctorate in comparative biology, what skills or expertise are they aiming to strengthen?
It really depends on what aspect of paleontology you want to go into. There's not a ton of universities that have a paleontology specific program. It does exist, but the most common thing that paleontologists or students aiming at paleontology will do is get a degree in biology or one in geology or both. My lifelong degrees are an even split between geology and biology. In terms of skills, the things that I think make the most sense, this might come from how and where I was trained, but phylogenetics,
Okay.
understanding how to put together these evolutionary trees, because that gives you the context for understanding how and when different behaviors evolved, when these transitions happened. It provides the context behind all of the other questions that you might have. So understanding how those trees are put together is important. In terms of my own training, I work with CT scanning, so 3D imaging technologies have become pretty important for being able to look at different structures in terms of micro scale, in terms of internal anatomy without damaging specimens. So that's important. Other places will train you in histology, so looking at what the different tissues are like in thin section, what that can tell you about growth or behaviors or metabolism, questions like that. It really depends on what sort of questions you're interested in, and that will guide what training you need. And that's purely from the academic point of view, research based. There's obviously science communication and prep work and field work and all sorts of other skills that are equally applicable.
And that is generally almost exclusively done on bones in paleontology. Would you do stuff on feathers? They wouldn't, or have they found a way to do that sort of work?
Yeah, so you can use different imaging. It's mostly like SEM type imaging on feathers. You can do chemical, like biochem analyses on feathers, looking at the internal structures of different parts. It's not in the realm of things that I do, so it's a little hard for me to answer that question.
Okay, yeah. Fair enough.
But mostly a lot of modern or more recent techniques in paleo involve looking at modern organisms and applying that information to extinct life. So a lot of my research actually happens on modern birds, and I infer things into the dinosaur record based on what I'm seeing in the modern world.
That's cool. So you mentioned phylogenies, and I think when my kid got back into dinosaurs, I had a chance after college to kind of review what I guess had happened over those couple years where I wasn't a kid, and then had a kid, and then so what happened in that 15 years in paleontology that I didn't know much about, and there was a lot, as you can imagine, and I think the most wonderful thing as a fan who just wants to enthuse over dinosaurs is the progress that has been made in filling out those phylogenetic trees. In that, yeah, you've got some tooth, but they can say, but this is a spinosaur tooth, and then you can learn so much more about the whole scheme of things as opposed to just what the tooth says. And then they do they can tell how many minerals or something like that were in the tooth, like how wet the environment was and things like that. Insane what they can infer, but the work that's been done is just mind-blowing. And so you can get these kind of ragtag collections of little bones that don't mean too much as in and of themselves. But when you put them into that comparative matrix, it's just incredible, the additions that little fragments can make on occasion, which is really neat.
That's part of the reason why going into the field and continuing to look for new species, new specimens, multiple individuals is so important, because it gives you not only just more data, but if you fill out a whole skeleton, a Spinosaurus is a classic example of this, because we had a skeleton that was discovered in like the 1910s. It was put on display. It got destroyed in World War II, so all of the information that we had on Spinosaurus was gone. And then we kept finding little bits of skull, little bits here and there, and it really wasn't until the 2010s that they found the rest of a Spinosaurus, like the rest of the body that wasn't part of the skull. And it completely changed our entire perspective on Spinosaurus. I went from this thing that was kind of T-Rex-ish in terms of being mostly bipedal, terrestrial, maybe semi-aquatic predator with a fancy sail on its back, to being this definitely mostly aquatic.
Yeah.
Changes in proportions, changes in body shape overall, that it's just incredible. And we wouldn't have gotten that if people didn't keep trying to find more specimens.
And even that in the early art, that crocodilian jaw or snout wasn't part of the reconstruction. Like, it just, so much was unknown. Can you imagine if Spinosaurus had that? Is it the gar? When you look at the gharials and they have that knob at the tip of their snout.
Yeah.
Can you imagine if they had that too? That'd have been so bizarre.
Yeah.
It's hard to say. So maybe in terms of comparative biology, we can kind of enter into the text in maybe this way. Jurassic Park is filled with the idea that dinosaurs are very closely related to birds. The animals in the novel are warm-blooded. They nest. They theoretically are aiming to migrate. There's evidence that they're trying to do that. They bob their heads and move like a chicken in a couple chapters. They chirp like birds and are just somebody's misled to believe that there is a bird on the window and it's really compies. And then they leave three-toed footprints. And Crichton says even that the juvenile Tyrannosaurus ducks its head in the water to catch fish from the lagoon, like a bird, he says. So the birdiness of dinosaurs sort of re-emerged in the 70s, I think, like when John Ostrom came up with the Deinonychus specimen. It sounds like that was like, hey guys, we gotta review this big lumbering perspective. But the revelation that dinosaurs and birds are closely related wasn't new. I think when you look back at, was it Thomas Henry Huxley was like in the 1860s, and he was like, these are really, really, really birdy in almost every way. Why did that bird concept fall from common knowledge for all those years? Like, what happened there?
I don't have a good answer for that. I know that Huxley had these thoughts, these ideas that dinosaurs are pretty birdy, depending on which dinosaur you're looking at. And I just feel like in reconstructing them, in the bone wars, in the rush to find all these specimens and put them on display, these earlier thoughts just got pushed aside, and whatever made them, maybe, I'm going to say this, and I feel like museums are going to come after me, maybe whatever made them easier to mount, which, when you're starting to mount specimens, it's hard to put a tail off the ground.
Okay.
So maybe that pushed aside all these earlier thoughts and made this public perception that dinosaurs were sluggish, that they dragged their tails, that they walked completely, like weird reptilian humanoids. Yeah, it really wasn't until the dinosaur renaissance that these ideas reemerged, and we stopped thinking of dinosaurs as these sluggish, cold-blooded, dumb, giant reptiles, and said something else.
And and these terrific reconstructions that are very bird-like, I think they look amazing, but it's how do I put this? It's so challenging to truly envision something standing like a bird, but also having so much mass in a tail. Like, that is so challenging to envision because nothing really has. And I don't know. Maybe you know way better than I do. Are there comparatives or analogs in the modern world that illustrate how that works?
So not really, because the bipedal nature of some of these dinosaurs, like clearly not all dinosaurs are bipedal, but the ones that are have these giant tail masses to balance out their torso and heads.
Mm-hmm.
And a lot of dinosaurs do this balancing act between either having a smaller head and long arms or a giant head and very small arms. But all of that front of hip mass is balanced out by the tail. So they're basically like seesaws on their hips. As theropods continue evolving and start to reduce their body size and become these smaller, fully feathered, very close to powered flight, if not already attaining powered flight, that tail mass starts to reduce and get thinner and get shorter and get smaller to the point where all modern birds are still built as these bipedal creatures. They still have that evolutionary history. But because they don't have that big tail mass, they have to change where their center of mass is. So they push that center of mass forward by actually bringing their femurs, their femora, to be horizontal, parallel with the ground. And so now their center of mass is at their knee instead of at their hip.
Okay.
And so when you're watching birds walk, their femora are actually being kept up close to the body. They're not doing a lot of rotation at the hip. They're doing most of their rotation at the knee. And so all of that center of mass gets shifted forward because they've lost this giant tail.
Okay. Is that why they hop a little bit?
No, the hopping is more of a behavioral adaptation to different locomotion, I think. But there's actually experiments done where people put, I would say, fancy plungers on the back of chickens to see how their locomotion changed. And they actually, because they now had this mass coming off the back that mimicked the tail, they changed their posture to shift that center of mass backwards.
That sounds a little cruel, but okay.
I'm sure it was all approved by the animal use
safe
committee.
as possible. So today it's commonly understood that, I think, crocodiles and birds are like the closest living relatives of dinosaurs. In terms of comparative biology, what can be learned by comparing fossils to existing crocodiles or birds?
So, like I said earlier, I use modern birds for my research. I look at dinosaur neurobiology, so looking at bird brains can actually tell us a lot about dinosaur brains and what parts of their brain they might have used for different behaviors and how that might have changed over time. But you can also look at things like biomechanics, how postures have changed. Crocs have this more sprawling posture where they hold their limbs out to the side and are basically doing this push-up all the time, which is a lot more energy intensive. Dinosaurs in their evolution rotated their limbs underneath their body. And I know this chapter talks about that, and walk more in an erect stance, which is way more efficient in terms of decoupling the use of your ribs for locomotion and your legs, right? So if you look at a lizard walking, they're using their ribs to help rotate their limbs, and that makes it hard to breathe and walk at the same time. But by changing your stance and rotating your legs underneath you, you can actually stop using your ribs to help you rotate your legs and become way more efficient at walking, which makes hunting easier, which makes migrating easier, which makes all of these other, developing a large body and things way easier. Respiration is another really interesting thing. So birds have this one-way system to breathe where air will pass through a series of air sacs before going through the lungs and then back out. So every time birds breathe in or out, fresh air is going into their lungs, which means they're getting oxygen much more rapidly than our silly system of breathing in and out through the same tube and inhaling stale air every time you inhale or exhale, or inhale rather. It was found out, I think, in the early 2010s, early 2000s, that crocodilians, monocrocs, have a similar system in their lungs, that their lung is actually subdivided into these little sacs, and the air passes in one direction through those sacs, which was fascinating because we didn't think that was a thing. We didn't think that was possible, but
Yeah.
So we're learning new things all the time, and we're able to use that information from modern organisms to understand when and how these changes happen in dinosaurs and what that would mean for their biology.
That's crazy stuff. And it explains why when birds can just continuously oxygenate their blood, it explains why they can just fly around at full speed but still scream at the same time. I wonder if dinosaurs would have been making like a lot of noise in the same way, just if they had that kind of lung structure or not. It's who
So
knows.
some dinosaurs definitely had one-way air sac-based respiratory systems. We know that for sure. Some of these air sacs get so big that they interact with the bones around them and start to carve out spaces in the bone. So
Really?
things like sauropods had air sac systems, theropods had them. It is uncertain, I think, at this point, if ornithischians had them because they might have had them and then they just weren't big enough to invade nearby bone, or they might have not had it. So I suspect that it's a pretty early dinosaurian evolution thing.
Is there any merit to comparing dinosaur fossils to mammals or fish? Or is there something like if they live in presumably similar ecosystems that you could see maybe convergent evolution? Is there any utility in doing that sort of work?
So, yes, I think so.
Mm-hmm.
So, comparing things to mammals is very tempting because
Okay.
we have so many mammals. Mammals have occupied every available environmental niche. They're also, warm-blooded. They, as if we ourselves are not mammals, um, evolved this erect stance that changes how efficient they are in locomotion. They do lots of things with teeth that help them digest food more efficiently. And in some cases, mammals are the best analog we have. So sometimes we don't have reptiles that have similar enough bodies to make inferences with. I saw a recent paper or talk at a conference where someone was comparing baby sauropods to, in terms of body proportions, to things like baby deer, because we don't really have long-necked quadrupedal
Mm-hmm.
reptiles. But like a deer has a pretty long neck and is quadrupedal. So in terms of body proportions, having this sort of gangly little baby sauropod, that might be a pretty good
That's kind of fun, yeah.
analog. Yeah. Um, yeah, so I think it depends on the situation. Mammals are quite different.
Yeah.
There's 300 million years of evolution between mammals and reptiles. So it does get difficult, but not impossible.
Because I took a very, very peripheral look at some of your academic papers, I can say in a very nondescript and nebulous term that you've studied bird brain cases and crocodile brain cases. Ish. Close to.
Ish. Yeah.
So I guess a two-part question would be: what sort of things do you discover when you make those investigations? And then the second would be: what might you
yeah, sure.
extrapolate from those observations to dinosaur brain cases?
So, in terms of crocodilian brain cases, that was the focus of my master's work. I was looking at how brain cases change over the lifespan of a single species, and how that can inform evolutionary relationships, because sometimes skull changes, especially if you're using features of the skull to construct a phylogenetic tree, if those skulls are changing drastically over ontogeny, so from being a baby to being an adult, they can obscure the relationships in the tree. And so maybe you want to be looking at these features in babies and infants before they mature to see what maybe the baseline, the more, quote, primitive state would have been.
Okay. Can I ask you about being a student?
Yeah.
All right. So throughout one's journey through academia, they have advisors who guide and oversee their progress and work, aiding them in various ways to become a published academic contributor. Is it common for, I guess, an advisor to be working or teaching in the same field of study as the degree that you are pursuing at that time?
Is it common for our advisors to have the same degree? Is that what the question was?
If you were getting a PhD in comparative biology, would your advisor also hold a PhD in comparative biology?
So, in the sciences, typically, yes.
Okay.
But So if you're pursuing a degree in physics, then your advisor should probably have a degree in physics.
Yeah.
For paleontology specifically, because it's so split between bio and geology programs, there is some chance that your advisor will not have exactly the same degree. So I think, if I'm remembering correctly, all of my advisors have had degrees in geology, if I'm remembering accurately.
Okay.
And mine is in bio. So that's fine.
All right. Because there's a question I have about the book, and it's that Dr. Sattler, or Ellie Sattler, is Grant's student, specifically said in the novel. And it's not really clear whether or not she's earned her PhD, although she's called a doctor, so I guess she has. But whether she's one of Grant's students or Grant's past students is immaterial in a way. But in either case, I just was wondering if it would be appropriate for a vertebrate paleontologist to have a paleobotanist as a student. Is that a kind of thing that's makes sense? And if it is, that's fine. But I wonder.
No, I don't think so.
Okay.
So different expertise can definitely serve on committees that aren't quite exactly what they work on, because sometimes it's more methods based, sometimes it's more organismal based.
Mm-hmm.
So sometimes people have experience in the method you're using, but they use it on a different group.
Mm-hmm.
And that's fine. But botany is very different from animal evolution. And so it would probably make more sense to have a botanist of some caliber, either modern or paleo, as an advisor for a botany project, I think, than having a vertebrate paleontologist be the PI, the direct advisor.
I kind of felt that way too, but I'm not a scientist. So I just wondered, I just wonder how he made. But maybe Grant was also, and it's just not mentioned, publishing on paleobotany as well. Maybe he has an equally useful career as a paleobotanist that isn't mentioned. Maybe.
Yeah, maybe. Or maybe he's using lab techniques, SEM, or spectrometry of some caliber that are relevant. Right, maybe she's a postdoc and doesn't need as much guidance.
Maybe. So she's 24 in the book.
Okay.
So I think Crichton might have just slipped up a little bit when he was writing that character, because there's a couple matters that don't line up really nice.
Yeah. She's
still a great hero, but she just seems a little young, just in an odd spot. Like he didn't spend a little extra time writing that character. That's how it feels a little bit. So you mentioned that we talked about advisors a little bit, and one of the people you've worked with has got to be a dinosaur consultant and advisor to a Jurassic Park film, which is kind of neat, which is very neat. So if you were an advisor or a consultant to one of the Jurassic Park films, would you incorporate an Alioramus or a Dodo?
Ooh. Oh man. Out of all the questions that I was mentally prepared for, that was not one of the ones.
Good.
Oh my goodness. I honestly would probably incorporate a Dodo.
I think you could surprise a lot of people with the Dodo.
I have a lot of love for the Dodo.
Mm-hmm.
And Alioramus would be cool, but I feel like everyone's already familiar with Hero.
Mm-hmm.
And if you're just... Alioramus is a really interesting Tyrannosaur relative, but people are familiar with the Dodo. It would be a chance to, rectify all of the nonsense around Dodo intelligence and other things. So
when you dug into the Dodo and found out, what did you? So the reports were much smarter. Well, you can tell me it wasn't as depicted in traditional literature. What did you find when you looked into how this big pigeon operates?
So I looked at brain volume versus body size for the Dodo and its closest relatives, which are a bunch of smaller bodied modern pigeons, and found that it really, for its body size, had an appropriate brain volume comparatively to the rest of the group. Now, birds vary tremendously in how brainy they are. So you have things like crows and parrots, which are exceptionally smart in the range of bird brain evolution. And things like, chickens that
Yeah, yeah.
are fine. But the dodo has long been shown as this very, very stupid, launching itself into volcanoes, driving itself to extinction type
Mm-hmm.
of organism, and that is not the case. According to this brain volume versus body size analysis that I did, its brain volume is proportional to its body size. So it would have been probably as smart as a modern pigeon, which, if you're looking at modern pigeons around New York City, might not be saying a lot because they're eating garbage and being generally pigeony.
Mm-hmm.
But, they were trained as messenger carriers in World War II. They have a lot of homing capabilities, a lot of like spatial recall, numerical discrimination, all of these things that you wouldn't think of necessarily when you think about pigeons.
Mm-hmm.
So dodos would have probably been just as capable of doing those things.
I'm sure when garbage or food is easy to come by, that your behavior doesn't become especially complicated. But I bet you if resources became scarce, you're right. The pigeon was probably going to be able to do some interesting things to overcome.
Yeah,
And it'd be fun if New York was full of dodos instead. That'd be a different.
it would.
The subway
It
rides.
would be interesting for sure.
Is there anything about the novel or the film that's troubled you, or you've ever wondered about, or any parts where you're like, geez, that just doesn't add up?
I'll say the feather coverage on the raptors
Mm-hmm.
bothers me a lot. And I know it's actually, according to the trailer for the new one,
Yeah.
they have rectified that. Finally, I cannot wait specifically for that moment in this movie. But yeah, we've known that dinosaurs, especially birdline dinosaurs, have been fully covered in feathers. We've known that since the 90s.
Mm-hmm.
And they made, well, I'm not a CG person or a movie maker, but to me, the paleontologists, it feels like they didn't put in a big effort to try to
Mm-hmm.
show that in a lot of the movies, even after it became scientific knowledge that this is the case. And I know when the first Jurassic Park came out, the CG capabilities were not there to be able to produce feathers in CG. So like that, I get.
Yeah.
They did a good job explaining it away in Jurassic World, the first one, where Dr. Wu was saying, "You didn't have me engineer dinosaurs, you made me engineer monsters."
Mm-hmm.
And I was like, fine, I'll allow it. But
And that's that. I think the book is pretty specific about, because there are these questions about they've made adjustments in the code and they've done things to make them a better adapted to, resilient to disease and things like that. But I think they're pretty clear about like what you get is about as authentic as possible. Like they didn't do a lot of like tweaking and weird stuff. And it's an interesting part in the book where they said, well, we irradiate the gonads. We make sure that we deny them certain chromosomes, and these are reasons why they'll never breed. And then there's like this amphibian DNA sort of explanation as to how that might have overcome. But then by the end of the book, they basically say, you know what, irradiation, that probably failed. We did it, but I bet you that doesn't work at all anyhow. Like they basically they walk back all of their explanations, just say, yeah, that stuff doesn't work, and that's why they're breeding. And I don't even know if the amphibian DNA explanation ever gets quite. I don't think that becomes the answer. I think it's just, they failed. They actually bred authentic dinosaurs, and all of their control mechanisms, they failed. It wasn't that the dinosaurs did anything special or their mutations in any way. The dinosaurs succeeded, and all of their control mechanisms are what failed. And it wasn't really delivered textually like that. It's just kind of said in passing. But I think it wasn't necessarily the frog DNA, although that comes up as an explanation. But they have explanations for all kind of stuff that they talk their way out of in the book too. So
yeah,
it's interesting.
For sure. Now that you mentioned the amphibian DNA, I honestly, since I'm so wrapped up in feather coverage, I always forget that that's a key point.
Mm-hmm.
And it just makes me wonder why they went with amphibians and not with modern crocs or birds that are way more closely related to anything dinosaurian than a frog would be. And it's just as easily accessible. It's not like frogs are more plentiful than crocs are birds,
Mm-hmm.
you know? So that's another thing that like never really made sense to me.
Yeah, I think
Is why
Crichton.
they chose frogs.
I think Crichton hears neat stuff. I think he was always going through the journals or reading his popular science, and I think he was really on the vanguard of like new ideas, and he was. Obviously, he was. And I think that must have been just some little factoid that he heard about, and he's like, "That's going in my book," because there's a bunch of things that he put in his book that don't really carry water, so to speak. And we were talking. I was talking to another guest, and he was talking about how this computer-assisted sonic tomography would be impractical in the field. You wouldn't use that. That diagnosing the tip of a velociraptor fossil emerging from the stone and say that is a infant velociraptor for sure would be impossible from.
Yeah.
So how familiar did you ever become with chaos theory? Because the answer is to everybody in the world, no, we're not, right?
Yeah, no, I can quote Ian Malcolm in the back of the Jeep, and that's about as close as I get to understanding chaos theory.
And as it's presented, it almost just comes out as a philosophy, like Marshall's rule. If something could go wrong, it will. It kind of feels more like that versus an actual calculation. It doesn't. I don't know what factors are put into the formula that creates the result. Like I just don't get it, and that's not really covered. But there's a part in the book where when I was looking into chaos theory so I could make any sense of it while I'm doing this thing, because that's I guess what this book is about, so I should do it. There's something called strange attractors, and I don't get it. They are so complicated to me. I cannot understand what they are, and they are fundamental in how chaos theory is unpredictable. Like they are consequential and they're important. And there's one line of text where Malcolm is asking Gennaro, "Are you familiar with strange attractors?" And this is in the film too, where he's talking to Dr. Sattler, and he says, "Strange attractors," in the car there, and they both go, "No," and that was it. That's it. He glosses right by. So he's got this cool thing. I don't know that he was ever really comprehensively well read on each of these subjects. He just kind of adds them in, and then as a common reader you just kind of gloss by them and you accept it. And I guess he was a magician in that way, that it might not have been,
the story is so compelling. The story is so compelling that you just glaze over the
may not have been
parts.
Good science, but it was a good story. And I think that's what they tell you. Don't let truth get in the way of a good story. Michael Crichton.
In terms of reading, like getting into the literature, I recently had this experience where I was reading a paper that is pretty outside of my general expertise in science, and I kept having to open up a new tab and Google, define this.
Yeah.
Define this. Oh, I should probably look into that. Like pull open Google Scholar and try to find this new paper. I went down the rabbit hole. So even scientists have this issue of when you're reading something that is outside of your
I entirely
field,
relate.
it gets complicated.
What is chaos theory? 13 tabs later, I don't know. The answer is I don't know what chaos theory is. I cannot make sense of it. Well, we're straight out of time, but was there anywhere where guests could go and find more of your YouTube video? You mentioned you got a terrific website that people could visit, perhaps. Is there somewhere people you can find your books and find your communications?
So, drneurosource.com, you can find links to the books, and that's my general blog, and then Science on the Street on YouTube.
This is great. Well, thank you so much for being a guest, and I hope you had fun.
Thank you for having me. Yeah, this was great.
Good. Tell all your friends. Well, I appreciate it. Thanks so much for joining me, taking a flyer on this, and going through the technical issues and things like that. I appreciate it.
No problem. This is super fun. I'm glad that we could make this happen.
So a big thank you to Dr. Eugenia Gold. Incredible insights there. It's so amazing to have these cool people come on to this goofy podcast. I'm not worthy. This week's text is the third iteration. We made it all the way in Jurassic Park, spanning from pages 81 to 87. Details emerge more clearly as the fractal curve is redrawn, the third iteration tells us. And as for our chapter, after observing the apatosaurs, our heroes head towards the safari lodge, and Sattler becomes concerned that perhaps the designers at Jurassic Park haven't been as careful as they should have been. They head to their rooms, and they get ready to take the tour. We have our characters like Ellie Sattler. Sattler tells Grant that the dinosaurs, quote, look pretty good. Then she checks out the plant's poolside and is concerned to find Serena veriformans, a highly toxic species of fern. She has a memorable novel moment where she thinks to herself, quote, people are so naive about plants. They choose plants for appearance, but never occurs to them that plants are living things busily performing the living functions of respiration, ingestion, excretion, reproduction, and defense. On page 85. They've evolved as competitively and fiercely as animals, and, quote, people who imagined that life on Earth consisted of animals moving against a green background seriously misunderstood what they were seeing. That green background was busily alive. Plants grew, moved, twisted, and turned, fighting for the sun, and they interacted continuously with animals, discouraging some with bark and thorns, poisoning others, and feeding still others to advance their own reproduction, to spread their pollen and seeds. It was a complex, dynamic process which she never ceased to find fascinating. On page 86, Sattler only suggests that the ferns around the pool are poisonous once she reconvenes with Grant in his bedroom after they've settled in for a bit. On page 87, and she's also noticed that the rooms have been retrofitted with protective bars. She's further noticed that the windows are smaller than they'd seen in the plans, and the glass is tempered and set in a steel frame. The doors are steel clad, and there's a 12-foot high, inch-thick steel fence surrounding the entire lodge. Dr. Alan Grant, he agrees with Sattler. The dinosaurs, quote, look good, and he wants to inspect them thoroughly, inspect their toe pads, claws, and teeth, feel their skin, and look in their jaws, to verify that these match the fossil record and are therefore indeed dinosaurs. Grant reflects upon the history of paleontology, giving us some perspective on the traditional, historical, and outdated perception of dinosaurs. Grant is revealed to be a, quote, key figure in the hot-blooded dinosaur debate, placing him in league with the alluded-to paleontologists of John Ostrom and Robert Bacher, whom we'll discuss further in the literary techniques section, and later on in the book as well. And later on in this podcast as well. But the introduction of cloned dinosaurs means the end of paleontology as Grant knows it. The museums, the labs, the fieldwork are all done. On page 84. But he doesn't seem upset. Apparently many people imagined that cloning dinosaurs was, quote, coming, but not so soon. Ian Malcolm. Ian suggests that the field of paleontology will forever change now that dinosaurs can be cloned. Wow, boy, is he ever clairvoyant. That's amazing. What an observation. But he observes that Grant doesn't seem upset, and that is kind of unusual. That's all Ian gets in this chapter. Ed Regis, he leads them from the helipad to their rooms at the Safari Lodge, lauding how entrancing the atmosphere is. He truly appreciates that the landscape genuinely recreates the feeling that you've traveled back in time. Isn't it wonderful? He thinks to himself, even though he's mistaken. The plants which contribute to this authentic atmosphere are deadly. I believe we're to read this as Regis being as naive as the people whom Sattler imagines. Sattler imagines Regis is like one of those people who seriously misunderstands what he's seeing, as she's quoted as saying earlier in the page. So we have also a kind of a perspective on dinosaurs here that we need to understand. Once believed to be cold-blooded, bent-legged sprawlers, hugging the ground for warmth like lizards without the energy to stand on their hind legs for more than a few seconds, Grant is said to have pioneered the concept that dinosaurs were hot-blooded, straight-legged, animals with high metabolisms, with complex social lives and child-rearing behaviors. These lessons are learned from animal posture, analyzing dinosaur trackways, considering the metabolism required to pump blood up an 18-foot neck, and that their fossils have been found in Arctic localities. They now believe to be quick-moving, active animals, we're told on page 84. In Grant's suite, we're told that there are 7 channels upon which to view the dinosaurs in their enclosures. We know that there are 15 species on the island, and here we get a preview of what we might see later in the novel. We get hypsilophodons, who have their own highlands, triceratops, who have their own territory, sauropods, we've met the apatosaurus already, who have their own swamp, carnivores, no mention of which carnivores we'll see yet, who have their own country, stegosaurs in the south, velociraptors, remember, Grant described them as pound for pound the most rapacious dinosaurs ever. They have their own valley, and pterosaurs, who live on a peak. And we can still hear the apatosaurs trumpeting off in the distance on page 84. No mention of other characters yet, like Dennis Nedry was on the flight with them. Doesn't come up. Donald Gennaro, he's there. Doesn't talk to them. John Hammond's walking back with them as well. We don't hear from that guy. They're just kind of overlooked. We have cool localities, actually, this time. The pool deck sounds really cool and is so easily overlooked because when Crichton mentions a pool at a hotel, we all think of a very regular rectangular pool surrounded by chain link fence, surrounded by a concrete patio like at every hotel pool deck we've ever been to. But this one is unlike those. Yes, there's a fence, but the swimming pool spills over into a series of waterfalls, which terminate in a small rocky pool below. So you can imagine that picturesque, shoulder-high ledge overlooking a cliff where the water flows over the side and then trickles down into a series of slight rockscapes, perhaps like you've seen in a Mexican resort. And recall the helipad is at the highest point of the island, the northern end, 2,000 feet above the ocean crashing below. Then they descend from the highest peak to the visitor area, which is probably still at quite the elevation, and this pool may overlook the park and valley below, filled with a misty rainforest. Maybe, extraordinary in an otherworldly view. But in any case, this isn't some terraformed flat-surfaced area. It's overlooking a slope of some sort, and it would sound very tranquil, the water trickling down. And we know from the chapter Plans that a Japanese landscaping firm designed the layout on page 52 and 53, we're told. So perhaps there's some sort of Zen garden element to this as well. And it's surrounded by foliage, including by huge ferns, which Sattler takes exception to. Regis tells us that it's extraordinary on page 85, and I imagine that it is. Jurassic Park, we're told a little bit more. We hear that on a misty day, Ed Regis tells us the authentic Jurassic ferns contribute to the, quote, prehistoric atmosphere on page 85. We get into the Safari Lodge, where people like to spend the nights. The Safari Lodge is a, quote, dramatic, low building with a series of glass pyramids on the roof. On page 86, we're told. And this is where guests stay while at Jurassic Park. Now, I've always envisioned this as having, like, 3 pyramidal skylights, but perhaps there's one over every suite. I'm not sure. If that's ever specifically stated, I have no idea why 3 skylights are in my mind's eye. But that's probably false. Also, note that this is specifically described as, quote, low, which means something which is surprisingly good at jumping might be able to get up on the roof. What are the odds of that happening later, huh? There's a 12-foot high, inch-thick steel fence surrounding the entire lodge, we're told on page 87. But that wasn't in the plans, but it's there now. And it looks like they've turned the place into a fortress, says Ellie. We get a little peek into Grant's room. The room is designed in beige tones and a green jungle print motif on the rattan furniture. For those who are unfamiliar, like me, rattan furniture is a sort of like wicker looking, and I believe it might be Japanese. It appears that it could be produced with bamboo or a type of cane wood, and you can imagine there being one of those folding Japanese-style changing blinds perhaps in the room as well. The room is unfinished, and stacks of lumber are in Grant's closet, and pieces of electrical conduit are on the floor. Grant has a television in the corner. This is described to eventually offer a video of the animals in their enclosures, and likely be limited probably only to that. You're likely not getting HBO. Although with Fire Sticks these days, all these years later, who knows what you can watch on there. There is more than one room, as he describes there being a distinct bedroom, and the pyramidal skylight is over his bed, which reproduces a tinted perspective, like sleeping under the stars, which is nice. But recall the island is almost perpetually covered in low fogs, so much so that it's named Cloud Island, or Isla Nublar. So in execution, this probably wouldn't offer much of a sight of the stars on a usual evening. We have some neat allusions and references. This one's a little passive, but I'm going to stick it in here anyhow. Alcatraz. In Grant's bedroom, he can't help but notice that the glass is protected by heavy bars, casting striped shadows across his bed on page 87. And upon reflecting upon the plans he'd seen, he doesn't remember seeing these bars. In fact, they appear to be a crude addition. The black steel frame is welded to the frame, and this puzzles Grant. While not specifically alluding to Alcatraz outright, like they don't say it's a jail or it's Alcatraz or anything like that, this does harken to prison imagery. The bars, the shadows of the bars, all create a jail-like atmosphere. The island already has been described like Alcatraz by Malcolm, only 10 pages ago, on page 77. John Ostrom and Robert Bacher at Yale recall that Dr. Grant is one of the, quote, principal advocates of the theory that dinosaurs were warm-blooded, on page 93, which places him among Robert Bacher and John Ostrom at Yale University. Robert Bacher published the groundbreaking book The Dinosaur Heresies in 1986 that made him a variety of convincing arguments that dinosaurs were warm-blooded. John Ostrom published on the Deinonychus in 1969. Deinonychus is, of course, the model upon which the velociraptors are based. And Ostrom said that this animal could never fit the perception of dinosaurs as lumbering, sluggish oafs deserving of extinction. It could only be the fossil remains of an incredibly agile, fast, and intelligent hunter. Together, Ostrom and Bacher were central in the hot-blooded debate and Crichton is sticking Dr. Grant among them to help use some of their cachet to imbue his hero with. Alice's Adventures in Wonderland, again, a passive allusion. Quote, they moved into a green tunnel of overarching palms leading toward the main visitor building. Everywhere, extensive and elaborate planting emphasized the feeling that they were entering a new world, a prehistoric tropical world, and leaving the normal world behind. On page 83. Straight up, this tunnel imagery is the rabbit hole that Alice descends through to enter into Wonderland. Very similar imagery, and the early references strongly reinforce that this is how to read it. We're now in a new land filled with strange monsters. And what kind of things do we find in Wonderland? Well, we get a homicidal monarch, like a T-Rex, maybe? A Mad Hatter. We already have Ian Malcolm describing himself like that. A Cheshire Cat. I don't know who that could be, but it could be fun. And there's more. Who knows how this analogy plays out? And there's so much to unpack that it'll be a fun activity to do one of these days. Stylistic techniques, we have foreshadowing or inciting incidents. The poor shrubbery selection identified by Sattler starts off with a concern that perhaps the designers of Jurassic Park haven't thought all their choices through well enough. And then they see that the most of the facilities have been retrofitted to make their safari lodge appear more like a fortress. What could have changed that led the designers to make such drastic upgrades to their facilities? We'll be sure to ask why, says Grant. Literary techniques, we have an analogy. Paleontology was essentially detective work, searching for clues in the fossil bones and the trackways of the long-vanished giants. The best paleontologists were the ones who could make the most clever deductions, we're told on page 83. I have a comment here on the dialogue. The dialogue is a bit stilted in this chapter, but serves to engage Dr. Grant's imagination once again, providing Crichton an opportunity to unpack what's going on through narrative perspective, and then gets really pretty bad on page 85 with this exchange. Ellie said, quote, you can't reproduce a real dinosaur because you can't get real dinosaur DNA. Unless there's a way we haven't thought of, Grant said. Like what? She said. I don't know, Grant said. Dr. Grant, what was that way that you haven't thought of yet? What is that? Well, I don't know. I haven't thought of it yet. That dialogue is all bad. Terrible. But that's okay. Motifs. The idea of responsibility and safety is alluded to here very clearly. The plants decorating the poolside are toxic and deadly, especially to children. It's an incredibly bad omen, that if it's any indication of how they've designed the rest of the facilities. And spoiler alert, it is. As Crichton spells it out, quote, if planting deadly ferns at poolside as any indication, then it was clear that the designers of Jurassic Park had not been as careful as they should have been, on page 86. And note, Sattler's observations are not shared with Regis, Hammond, or the park people. I guess she was waiting to put it in her report after the consultation? I never think about that these people have paperwork to do afterwards. They need to offer their opinions as consultants. Other notes on safety and responsibility. The rooms have been retrofitted with protective bars. Ellie further noticed that the windows are smaller than they'd been seen in the plans, that the glass is tempered and set in a steel frame, the doors are steel clad, and there's a 12-foot high, inch-thick steel fence surrounding the entire lodge. Heroes and villains. We're told that the best paleontologists, or heroes, are the ones who could make the most clever deductions. That paleontology was essentially detective work, searching for clues in the fossil bones and trackways of the long-vanished giants. The best paleontologists were the ones who could make the most clever deductions, on page 83. So, like I said, here's Columbo reappearing for us, or at least to me. There's nothing that directly relates Grant to Columbo overtly. That's a perspective as an entire fantasy of my own, but it's worth saying. Crichton envisions his Grant as a detective as well, and a brilliant one, like Columbo. Discussion. Regis is a liar, or maybe he's just always wrong. We'll have to figure out what exactly he's saying, but earlier I posited that we cannot trust Ed Regis, that everything he says is a lie or some kind of spin enabling Hammond and Jurassic Park to continue to move forward as bad actors. Our earliest meeting with Regis was during the backhoe accident at the beginning of the book, where he lied straight-faced to a doctor while trying to save a construction worker, and I outlined how pretty much everything he said was likely an untruth, designed to avoid being responsible for the harms that have been committed, and in that case, a young man's death. In this chapter, Regis isn't necessarily lying, I don't think, but he's totally wrong, again, with serious consequences. So perhaps he's not necessarily a liar, but he's not someone you can trust for accurate, actionable information. In this case, he thinks the ferns around the swimming pool are great, and that they greatly contribute to the Jurassic atmosphere. But Sattler, of course, quickly identifies the ferns as being a common species, quote, found abundantly in fossils more than 200 million years old, that are known to grow spores that contain a deadly beta-carboline alkaloid on page 85. And then we get into paleobotany for the first time kind of in this book. The Serena veriformans is a fictional plant that Crichton dreamt up to include in the novel. So he has creative license on its reality. And in this case, it's a plant where even touching the attractive green fronds could make you very sick. And if a child were to take a mouthful, he would almost certainly die. The toxin was 50 times more poisonous than oleander. On page 85, we're told this. For reference, apparently, oleander, when dry, is toxic, and a single leaf could be lethal to a child eating it, though apparently mortality is generally very low in humans, according to a paper at Colorado State University. A lethal dose for cattle and horses, significantly larger animals than a child or a person, is said to be 0.005% of the animal's body weight. That suggests that a 60-pound kid would only require about 1.5 grams of oleander to ingest a fatal dose. If Serena veriformans is 50 times more toxic, then we're talking 1.5 grams divided by 50, which is 30 milligrams. A very little bit, which still would be odd to get into your mouth, but it wouldn't take much of it. I mean, if the spores were to land in the pool, and you were to get pool water in your mouth, I guess there's a chance it'd cause discomfort while you're visiting. So in practicality, you'd think, if, quote, even touching the attractive green fronds could make you sick, and construction had been going on for 2 years around these plants, that, a gardener has been pruning these things or cleaning up after and caring for these plants, that someone, like the pool boy or the gardener, might have already noticed that these ferns were trouble, but they haven't. Were these plants cloned? Are they prehistoric? No. We're told that these plants, though abundant in the fossil record, fictionally, remember, these are fake plants, are presently found in the wetlands of Brazil and Colombia. But not really. Remember, they're fake. So Jurassic Park has imported these plants. And if this is the case, that we're living in a world where Serena veriformans is a real known plant imported from South America to feature poolside at Jurassic Park, then present-day botanists and gardeners would know about this real plant from their world, and also that it's toxic. So that's a big fail in the Japanese landscaping firm that they've employed. Like, when you read this, there's this presumption that these are ancient plants that aren't commonly known because they're extinct, and only Ellie Sattler has the expertise to realize that these plants are dangerous, but that's not true. These are just South American plants. Apparently, they've been quite famous plants, too. If they're known to be 50 times more toxic than oleander, then they've truly chosen poorly. But this gives us a chance to have Ellie exposit her thoughts on the competitive and often overlooked lives of plants. And, that's important because that's one of the most memorable moments from the novel. Like, when you finish the book, you go, boy, yeah, I really remember that part about plants. Her discussion on how plants are as equally engaged in the biosphere as animals are, that people only see, quote, animals moving against a green backdrop, seriously misunderstood what they were seeing because the, quote, green background was busily alive. And this is memorable because it's a revelation. It's true. We can all appreciate how it may broaden our perspective on the world. Suddenly, the biosphere, the world around us, is far more interactive, engaging, and alive. And that's fascinating. A truly enlightening moment, which I think Crichton is famous for delivering. Reading his novels expand the horizons of what's possible. Not for real, just in our own perceptions. It broadens our minds, however fictitiously. And we often finish his books with an enlightened perspective, making him more than just a sci-fi action-adventure writer, but also a source of wonder and inspiration. And Ellie Sattler is the agent that delivers one of these first moments for us, endearing her character to our sensibilities. Cloning dinosaurs. Grant's apparently read up on the literature of cloning dinosaurs. He knows about this stuff, but knows that it chiefly requires dinosaur DNA. And where does one get that? In this world, there is serious speculation in laboratories at Berkeley, Tokyo, and London that cloning dinosaurs might be possible, but fossilization destroys most DNA, replacing it with inorganic material, and no frozen or mummified dinosaurs, or one preserved in a peat bog, have yet been discovered. We're told on page 84 and 85. Paradigm shifts. Quote, everything changes, says Grant in this chapter, which was forewarned in the introduction, that biotechnology is going to change everything, the face of the earth, and the world will enter into a new age as a result, similar to the atomic age and the computer age. And then we shift into Grant's discussion into the modern dinosaur age, describing how the field of paleontology has grown in the past 150 years. This helps link us to the chapter, quote, almost paradigm, which will come much later, and the comments that Malcolm will later make about how unpredictable changes can be. Ultimately, the comment is, once a new power is unleashed, it's impossible to predict what will come of it or, put different, chaos is sure to follow. Malcolm is closely tied to the concept of changes and how they're unpredictable, and even worse, that the unpredictable nature may be chaotic, or put different, out of control. The opposite of chaos is order, which is manifested in this novel as, quote, control. And in fact, like a half dozen chapters are called Control, where agents of Jurassic Park sit in a room named Control, and they aim to thrust a sense of order upon Jurassic Park. Of course, with unexpectedly devastating results. Quote, now, if dinosaurs could be cloned, why, Grant's field of study was going to change instantly. The paleontological study of dinosaurs was finished. The whole enterprise, the museum halls with their giant skeletons and flocks of echoing school children, the university laboratories with their bone trays, the research papers, the journals, all of it was going to end. Malcolm somewhat echoes Grant's disbelief in cloning dinosaurs. Not that they did it, but rather that it's happened so quickly. Quote, everybody knows it's coming, but not so soon, replies Malcolm, saying that it's the story of our species. The change comes before we're ready. The iterations, what do these mean? What are they suggesting? We've considered that they're Crichton suggesting that we should read this text through the lens of chaos theory. We've suggested that the iterations may serve as act breaks, that they each tell a story or a short story that introduces and answers a mystery while moving the story forward. Quote, details emerge more clearly as the fractal curve is redrawn, is our quote for this iteration. Ultimately, these appear to be describing the shape that the modeling plots out. And that shape, I guess, provides something like a graph or a chart in terms of graphically illustrating the modeling's outcome, from which analyses and probably conclusions can be drawn from. In the first iteration, Malcolm's quoted as saying that there are, quote, a few clues to the underlying mathematical structure to be seen. I guess that means that upon running the modeling, it initially doesn't draw a curve that sets off any red flags right away. But by the second iterations, quote, sudden changes may appear. These changes are unpredictable according to chaos theory because of the variability in initial conditions. However, once those unpredictable changes are modeled, details emerge more clearly. I think that's where we're at. I guess we can read that as the shape of the curve is beginning to take a shape that is identifiable or meaningful to whomever would be performing the analyses. Is that even a useful analysis, what I've just provided for you there? Well, if it is, you're welcome. Dinosaurs. We have to consider the general public's perception of dinosaurs when reading this novel, through the lens that the author and podcast guest from episode 15 Airport, Robbie Dorman, called the genre fiction reader, or the general audience, and Crichton describes this here. There was a long-standing belief that dinosaurs were cold-blooded, and a fundamental belief that only cold-blooded, stupid, lumbering, unfit animals could ever let themselves become extinct. There was a Victorian-aged idea that dinosaurs were so stupid, so sluggish, so helpless, so unfit that they failed themselves, and are gone as a result. How else, posited the earliest of early dinosaur thinkers of the time, would an animal become extinct? And that perception of bloated, boorish, and helpless oafs permeated the early characterization and understanding of dinosaurs, which consequentially inseminated the zeitgeist in perpetuity for almost 100 years. Pot-bellied and sprawling dimwits with scarce enough energy to survive were taken from this earth because they were the opposite of what Charles Darwin's theory of evolution was suggesting. If survival of the fittest drove natural selection, then the opposite would be true of those that were selected for extinction. We still have the old political criticism that someone or something is a, quote, dinosaur, which carries with it the connotation that they're out of touch, unfit for the modern age, and are doomed to go the way of the dinosaurs. This perception of dinosaurs is what Crichton is playing on when he writes his novel, banking on the idea that readers imagine dinosaurs through this lens, whereas he's employing in a very Crichton-esque fashion the latest in scientific knowledge to shock and surprise readers. Quote, scientists had always classified dinosaurs as reptiles, cold-blooded creatures drawing the heat they needed for life from the environment, says the novel on page 83. Quote, a mammal can metabolize food to produce bodily warmth, but a reptile could not, suggesting this is why mammals have dominated the earth while dinosaurs have gone extinct. But Crichton reveals that science has moved beyond that perception. Later, in that same paragraph, we're told, quote, a handful of researchers began to suspect that the concept of sluggish, cold-blooded dinosaurs is inadequate to explain the fossil record. Crichton is saying, guess what, guys? Dinosaurs aren't what you think they are. Here's a whole damn novel about it. And so we get a cutting-edge perspective on computer technology, cloning technology, biotechnology, and dinosaur science, all wrapped into an action-adventure sci-fi thriller, which is pretty cool. Feminism, Sattler's first line is remarking that dinosaurs look good on page 83. Consider she was just finished being awestruck by the apatosaurus and talking about Malcolm's fashion choices on the plane right here, and that's all she's done since surprising Gennaro with her gender. Thankfully, her expertise has a moment to shine in this chapter with all of the botany. Timeline, I have an imperfect timeline, but I've reviewed the details closely and feel that this is fairly viable interpretation, which of course has plenty of wiggle room to start. If the helicopter departs Costa Rica at 10 a.m., and it takes about 40 minutes to fly to Isla Nublar, for the team to travel and deplane the helicopter, they should be spotting the apatosaurs around 11 a.m. They enjoy the apatosaurs, pee their pants a bit, then travel past the swimming pools and stop by their suites at the Safari Lodge, unpacking and changing their shorts for maybe 30 or 45 minutes, I don't know. And the tour starts, we're told, in about 20 minutes. So that means that the next chapter, where they're briefed by Gennaro about what their duties are as safety inspectors, likely occurs over the lunch hour. All right, we covered a lot of stuff today. Want to sign off today thanking you for joining me. If you want to read along in the book, add some thoughts to what we've been discussing on the show, or be a guest on the show and chat with me about anything you like about Jurassic Park, you can do that by connecting with me. I'm at ryansrogers@gmail.com. If you'd like to be a guest, drop me a line and we can try and set something up. We can rehash and tear down and gush over and chit-chat about any part of the book, or also not the book, all you'd like. The Jurassic Park-Cast is part of the Spring Chickens banner of amateur intellectual properties, including the Spring Chickens Funny Pages, Tomb of the Undead graphic novel, the Second Lapse graphic novelettes, The Infantry, and the worst of them all, the King Street Capers. And you can find links to all that baggage in the show notes or by visiting the schickens.blogspot.com, or finding us on Facebook at facebook.com/springchickencapers. For me, you can find me, I'm on Twitter at RogersRyan22. Thank you dearly for tuning into the Jurassic Park-Cast, the Jurassic Park podcast where we talk about the novel Jurassic Park, and also Not Dead 2. Until next time.